Hello.
Hello.
Hi.
Yes, you wanna try sharing your screen?
Okay. Hi.
Cái này cậu không liên lạc với tớ được, cái bên kia nó điều khiển, tớ làm sao tớ ngồi ở đây tớ điều khiển được.
Nurun, can you share your screen now?
Wait now. There is error at the setting.
So can you hear me?
Yes, Mr. Tuan, I can hear you.
Yeah, but I have not seen any in the screen.
You can see the slide?
No slide. I can see the slide, but I think it is very good chance to see together. Now yes. Now I can see. Yes.
Yeah.
Okay. Hi, Komasu-san.
Hi, Tuan-san.
Good.
Yeah. Okay. Oh, yeah.
Komasu-san.
Hi.
With Phan Minh Thu have just called me. He have a problem on the way, so he will a little bit join late.
Okay, so we change the order of the presentation.
Yeah, you can
Okay.
start others and to read.
Yeah, okay.
Biasalah Mac, tapi sebelum ni pakai okey je.
Siapa punya ni?
Saya tapi dah lama dah tak pakai.
So we start from so Nadia-san. We will start.
Yes, bro.
From Nadia-san.
Yes, bro.
Famintu is how to say he has a traffic jam and he will come to institute later. So please start from first. I introduce our session and after that, please start your. I ask you to make your presentation instead of Famintu. Okay.
Okay.
Nadia-san. Okay, thank you. So the others are also same. The order is how do you say changed. So we skip the Famintu. Okay. And when he arrives at the institute, we ask him to make his presentation. So 4 minutes.
So Mr. Komatsu-san, can you see the screen sharing? The housekeeping.
Sharing.
Yes.
Yeah,
Can you see
I
it?
share.
No,
Okay.
no. The screen on the screen now, the housekeeping on the screen. Can you see it?
Okay, I can see it. No
Yes.
problem.
Okay.
I cannot see.
Mr. Sam, can you check your microphone?
I cannot see your presentation.
Mr. Sam, please check your microphone connection. I
Yeah.
think it's
Very loud.
yeah, it's very loud and
Noisy.
yes. So
Sam, please.
Komatsu-san,
Yes.
after you introduce about the housekeeping, and don't forget to
Group photo.
group photo.
Group
Yes.
photo. Okay, I put the slide at the end of my presentation.
Okay.
Introduce.
You want me to sharing the housekeeping for you, or you wanna share your slide?
I use my by myself. If
Oh, okay, sure.
it doesn't work, I ask you to make how do you say show my slides. But I try to use my presentation.
Okay, you can share it now.
Now, okay. How about okay?
Yes, yeah, it's okay. Your screen.
Can you see? Okay.
It's in the presentation mode now. Can you switch?
Uh-huh.
It's not full screen.
Okay. I forgot my. Yeah. Okay. Is it okay?
Yes, it's full screen now. Thank you.
Yeah. Okay. Now we start. Okay. Good morning, everybody. Thank you for participation to this incubator workshop. So this workshop is advanced the application of remote sensing to coastal habitat mapping and monitoring. Conveners I and also Dr. Boshi Tuan. On behalf of conveners, I introduce this objective of this session. So first, what are coastal habitats? Coastal habitats are seagrass beds, seaweed beds, coral reefs, salt marshes, mangroves. You can see this is seagrass, and this is sargassum, and center is coral reefs, and salt marshes, and the mangroves. They are ecosystem engineers. They produce their own environment. It's all it's organisms who produce their own systems, and it's a very productive and make habitats for many species. And for example, this is ecosystem services of coastal habitats and example of seagrass beds. It's a tropical seagrass beds. Left-hand side is key ecosystem services. You can read the some 5 services. For example, seagrass meadows trap sediments and nutrients recycling, and seagrass meadows provide a nursery for finfish and shellfish. And also some squid spawn on the seagrasses. And seagrasses and associated algae have high primary productivity. So they absorb CO2 and produce start the food chains. And seagrass promote trophic transfer, not trophic, trophic transfers and cross-habitat utilization. And tropical seagrass provide food for dugongs and turtles. It's fosters biodiversity in the coastal ecosystem. But the major loss is these kind of coastal habitats are threatened by human impacts. For example, right-hand side, you can see coastal salinity change because of all that water and the pulse turbidity exacerbated by erosion due to land management, poor land management, and large sea-witching grazing events, eutrophication resulting in high plant blooms to make poor transparency, and dredging and boating effects, for example. So we need to conserve important coastal habitats that provide the ecosystem services to the society. This is indispensable for sustainable development. So, and we control human impacts within the limit of the Earth even. So remote sensing, but for this purpose, we need to where the important coastal habitats are distributed, and we need to know and to provide this data to decision makers and the stakeholders. So remote sensing is very important for sustainable development. So WESTPAC Ocean Remote Sensing Project has focused on coastal habitat mapping, this project has developed a simple and efficient method of water column collection and ground truthing suitable for subtidal zone, and applied a standardized method to map seagrass and seaweed beds, coral reefs in a subtidal zone in member countries, and now has broadened target habitats to other coastal habitats such as mangrove forests. This is our present situation of our project. And what is water column collection? This is some schematic diagram. Left-hand side is before radiometric collection. This is a horizontal view from the space. Right-hand side is a deep water. So the reflection from the bottom is decreased by a water column. And the perspective view is like this. So the deep water is very dark. And we applied the water column collection right-hand side after radiometric collections. You can see we remove the water column. So we can see the distribution of seagrass and the seaweeds. This is the water column collections. And we use depth invariant index and also bottom reflectance index. And this why we choose these methods, it's very simple and efficient. And we apply to many areas. But when the shallow waters, we don't need to use this kind of corrections because we can see the bottom very clear. And also we need to ground truthing. The ground truthing is very important for the classification. For example, supervised classification method requires very good ground truth data. And also the classification results must be evaluated with the ground truth data. So we propose to use the Manta tool left-hand side, and also bamboo camera. It's a pole and a GPS and a camera, and we can get this kind of view. And also echo sounder, and we can see this is a seagrass bed in Seto Inland Sea. Is a sea bottom, and the vertical view is Zostera marina is like this. And so we use drop cameras. The important thing is a ground truthing. Satellite image has some, for example, Landsat 8 has a 30 meter by 30 meter. So we need to make some representative location that shows a class over for classification. And now the satellite matchband images are freely available on the web. For example, Landsat series and the Landsat 8 ORI and Sentinel-2A and Sentinel-2B, and these are archived arrows provided by Landsat. I forgot like a Landsat. So these are freely available satellite multiband images promote the analysis of temporal and spatial changes in coastal habitat based on the archived images. And monitoring coastal habitats with satellite image analysis can be possible because, for example, Sentinel-2A and 2B has provide more frequent satellite images. So we have more possibility to get the clear satellite images. So these conditions promote the use of satellite analysis for the conservation of coastal habitat mapping. So incubator workshop objectives are to share several application cases on coastal habitat mapping and to analyze technological limitations and knowledge gap between research and conservation, to explore how to advance remote sensing technology and its application, to generate solutions to coastal habitat conservation. And these are the very important for points, because if we obtain some, output from these discussions, they contribute to UN Decade of Ocean Science for Sustainable Development, and also eventually SDGs. So we hope to share some these output or some results of remote sensing coastal habitat mapping, and we can discuss these 4 topics in this workshop. So I ask you to participate in this workshop and exchange active opinions. So the program is session 1 is a coastal habitat mapping for ICAM, and one, importance of coastal habitat mapping for ICAM by farming tool, and coastal habitat mapping and its contribution to conservation in Malaysia. Nadia will present this. And coastal habitat mapping in Maluku province, Indonesia, to support the SDGs 14 goal. And long-term changes in the coral reef ecosystem and human impacts in Spelmonte Archipelago by Nurjana. And the session 2, discussion discussion on coastal habitat mapping and ICAM and beyond ICAM. Requested discussant, Michida-san, and also Milika-san on the blue carbon, and Michida-san on the marine spatial planning and the coastal habitat mapping. So we start the program. I use, and we take the group photos. How do we take group photos? I don't know.
Everyone
Can you
can turn on the camera to take a group photo together, please?
Oh, I take 50 minutes. Sorry. How do you take the picture? I don't know. Gallery? Okay.
Yes.
Professor Combs, don't worry, the admin will take the photo, right? The admin.
Oh, okay. Okay. Thank you.
Yes, I will snap the photo for you guys.
Okay. So when you finish the photo, please announce me.
Yes. Everyone can turn on the camera.
Okay.
Yes. Okay. Last shot. I will count on 5.
Yes.
So you can eye contact to your camera. So 5, 4, 3, 2, 1. Thank you, everyone.
Thank you. Thank you. So now we start the first presentation. But farming is now traffic jam, so we start from the Nadia-san's presentation on behalf of ID and Mazlan-san from Malaysia. So please start the presentation, Nadia-san.
Hi, good morning, everyone. Can you see the slide?
Yes.
Okay, thank you.
Yes.
Okay, good morning. My name is Nurul Nadia Yahya. I'm from Geoscience and Digital Earth Center from University Technology Malaysia. So for today, I will present a title, namely Coastal Habitat Mapping and its contribution to conservation in Malaysia. Okay, today also I will present on behalf of Prof. ID from University Malaysia Terengganu. The title of his presentation is drone mapping for benthic habitat mapping. Okay, coastal habitat plays an ecological important role in coastal and estuarine environments. It provides different ecological functions and services to the coastal ecosystem, including carbon sequestration. Coastal habitat plays a critical role in maintaining coastal ecosystem structure and functioning. They have various roles, including ecosystem services. Despite their greater ecological significance, it remains risky where human easily destroy their populations due to rapid coastal development. Okay, the aim of this study is to map coastal habitats using Pleiades imagery at Merambung Shoal, Johor, Malaysia, using bottom reflectance index, BRI, after the development of the reclamation activities, which is forestity. The second objective is to conservation activities in study area. Okay, here is the map of the Merambung Shoal. As you can see that it is located in front of the Singapore, and here is the bridge connecting Malaysia and Singapore. Here is the Merambung Shoal. It has many habitat marine life here, and also Tanjung Adang. And here is the port, international Tanjung Pelepas Port. And here is the Forest City, the new development located here. Okay, Forest City development has been developed since January 2014. It is an integrated residential development located at Gelang Patah, Johor, Malaysia. Okay. Actually, they plan to build four islands here. However, for today, only Island 1 is successfully developed.
Narul, could you make the full screen presentation?
Oh, full screen. Sorry. Okay, sorry. Okay, here, of course, it has an environment impact because the area that they develop. They make the development here contain the seagrass meadow, and also has what is it that and also has mangrove forest reserve. But however, due to some circumstances, the development still being proceed. Okay. Despite being marketed as an energy efficient, ecologically sensitive, land conserving, low polluting offshore city, the development has had significant negative environmental impact with irreversible damage due to reclamation of ecologically sensitive coastal wetland. Okay. In here, there has many researchers highlight that there has many effect due to the development of the forest city, which is they will affect the water currents, which is they will affect the speed of the water currents, and also the navigational safety, and also erosion effect for the shoreline here, and also it has changes in water quality effect for coastal and marine environment, especially. Okay, here is the satellite image that captured Merambung Shoal from 2001. We can see that no activities here. Okay, here is the polygon of the forest city. And here, 2015, the development is has made active activities there. There has a lot of reclamation activities. For 2019, they already successfully reclaimed their area and developed all the building up. Okay, this is the new Google Earth image for this year, 2021. Okay, the study areas covered by mudflats, reclaimed land, seagrasses, and seaweed in the Merambung Shoal. The boundaries of Merambong and Tanjung Adang seagrass meadows, seaweed, and reclaimed land were obtained through in situ surveys on 17 November 2021 during a high tide. Total of 107 ground truth records, of which 39 and 68 coordinates represented seagrass and seaweed, where the linear extent of stretches was identified using a handheld GPS. For this in situ surveys, we also used GoPro camera because this is a high tide, so we don't have expertise to dive. So we just record using GoPro. Okay, here is the map of the sea truth data that obtained on 17 November. You can see that up here, we can see seaweed and several seagrass here. For here, this is at Tanjung Adang, we has a lot of seagrass. The type of seagrass is majority of still and Hellas acorites. Okay, we can see that here for the seaweed location, actually before this area is a seagrass area, but then after we came, the seagrass had been changed to seaweed. The species of seaweed appears here is ulva species. There's a very dense here for seaweed. And some patches of seagrass here. The species, namely still and Harris acorites. For at Tanjung Adang here, there's a variety of seagrass which has Halophila spinulosa, Halophila ovalis, and also Anhelus acorites. Okay, here is the satellite imagery that we bought using our grind. This is Pleiades imagery, which is high resolution. The date of the acquisition is 10 March 2021. The image was cropped to the extent of the Sungai Pula estuary. A subset image contain seagrass meadow, seaweed, coastal reclamation, related areas, and the surrounding subtidal and intertidal mudflats on the Sungai Pulai estuary. This is the best image that we can get from Pleiades. Actually, we try to get another high resolution imagery like world view, but maybe later we will buy. Also, we plan to fly a drone here. Actually, last week we went to this area, but unsuccessfully fly the drone here. Okay, for the image processing, the mapping and change detection procedure used in association with the Landsat imagery included 3 major pre-processing steps, which is radiometric correction, atmospheric correction, we use flash, sun glint correction, because there is a glinted, on the image has a glinted imagery, okay, on the ocean. And lastly, we do the water column correction for retrieving bottom reflectance. For atmospheric correction and also radiometric correction, we use NV 5.3. Okay, for atmospheric correction, we use flash algorithm using tropical atmosphere model and maritime aerosol model. The BRI, bottom refractor index water column correction approach, was applied to image as described in the previous study. Okay, here is the result of the from the satellite image. We can see that the blue color is the seaweed, Okay, and the pink color is the citrus for seaweed. You can see that from the classification, it extends to the below line, and also has a scattered of seagrass here. Okay, for at Tanjung Adang area, we can see that a lot of seagrass here, and also some scattered seaweed here. Okay, here is the accuracy assessment of the study. We obtained 71.6% overall accuracy for the processing. Okay, here is the conservation activities that had been done at the study area. Actually, the continuous observation had been done since 2009. We started map the Marambong Shoal since 2009. Okay, since before the development of forestry. But now, the port management from the Tanjung Pelepas port, they built a skirting made from iron, to conserve the seagrass at Tanjung Adang area. Okay, the red line is the skirting. They put the skirting all over the red line here, about 1.2 kilometer. Okay, in order to conserve the seagrass from it being sucked up by the due to development, or maybe they want to prevent the seagrass from sink. Okay. The present water depth information for BRI method need to be updated. Therefore, another fieldwork need to be carried on. Okay, due to the different water level at the study area, so another fieldwork need to be carried on. Then the second, the distribution of seagrass and seaweed may be affected by the development of forestry. As you can see that seaweed is the dominant species at the Marambong Shoal. But before this, only seagrass there, only patches of seaweed. But now, seaweed dominant is the dominant species at Marambong Shoal. The level of water clarity in Marambong Shoal actually not so clear. So it has a gel of water type 2 to 3, which is water clarity low, may affect the result of the classification accuracy. And then number 4, the distribution of citrus need to be well distributed. Okay, so therefore, after this, we need to go again to do the fieldwork. And then the seabed was dominated from seagrass to seaweed, which is uva species, and Marambong Shoal, as I mentioned before this. Okay, as a conclusion, the present study showed that remote sensing technology using Pleiades imagery is a promising tool to map seagrass and seaweed distribution. The conservation and management of seagrass resources, where reclamation activities pose a threat to marine and coastal ecosystem, and historical data, poor areas, and consequently, impact of reclamation is difficult to measure. The approach outlined in this study will enable management agencies to map coastal areas and to monitor the environmental impact of reclamation activities at broad spatial and temporal scales with minimum dependency on field data, and help identifying where management actions would be best targeted. Okay, now let me present Prof. ID's part. Okay, the title of his research is Benthic Habitat Mapping Using Drone at Redang Island, Malaysia. Okay, for this study, they use DJI Matrix 100. Before they flew, okay, they need the UAV need to be set up. Okay, they use a multispectral camera for multispectral drone imagery. And also the image, after they get the image, the imagery process, and they did the georeference, and then finally mosaic all the image. Okay, here is the methodology of the drone mapping. Okay, UAV photogrammetric mapping using multispectral imagery before they board the flight. Okay, they need to check the battery status, and then they need to set the flight path heading towards waypoints, cruising speed, altitude, using the wireless controller. Okay, and then they also need to check the sensors configurations, and then finally the reflectance calibration panel images. Okay, after the flight, the reflectance panel images were obtained, and then images will be selected, which one shows the best image, and then after that the image processing is being done. It included the mosaicing process. Okay, here is the image. Okay, the image of the drone. Okay, the multispectral images stitching technique is used, where structure from motion SFM photogrammetry were used. Okay, the process is like as stated here, auto mosaicing and georeferencing, and then the image corrections, and then the output and analysis, and finally the image can be applied for environmental monitoring. Okay, here is the image of the orthophoto, the final image, the mosaicing image of the Pulau Redang. The height of the drone during the captured image is 130 meter, and the size, the pixel size is 8.79 centimeter. Okay, here is the result from the drone imagery using supervised classification, maximum likelihood. Okay, you can see that it can detect very tiny patches. Okay, like coral, sand. Okay, as for now, that's for me. I would like to acknowledge Ministry of Higher Education Malaysia in order to support the grant, and also thank you to University of Technology in order to support my research. Okay, that's all from me. Thank you.
Thank you very much, Nadia-san. The time is past nearly 20 minutes, so if the audience have some questions, please ask via chat or after the general discussions. Okay, so thank you very much, and we move to next speaker. Next speaker is coastal habitat mapping in Maluku province in Indonesia to support the SDGs 14th goal. So Professor Sam Wotrizen from Indonesia, DP, please.
Thank you, Mr. Chairman. Let me share my slide first.
Hello, Kobasu.
Yes.
Can we speak now? Because I had on the chip now, so that I.
Okay.
Yes,
so
please.
Sam, Famin to arrived at the institute, so he will. Okay, Sam. Sorry.
Okay.
Okay. So.
Okay, never mind. Yeah.
So.
I'm sorry for that one because I on the chip, so that I cannot follow on the meeting here. So I just come here to present my presentation here first.
Okay, it's okay. Yeah.
Yes. May I say screen?
Yeah.
Yes, you can see my strip.
Yes.
Ladies and gentlemen, my name is Phạm Minh Thổ. I'm from Institute of Oceanography in Vietnam. On behalf of my group, I would like to presentation the topic importance of coastal habitat mapping for integrated coastal area management. Yes, the first one, I would like to target to about the sustainable development. This is the concept. The first presentation in 1987. This is development that need the needs of this is the development that needs the need of the presentation without the commission, the ability of further generation to meet their own need. And following for that one, the sustainable development following the three dimensions is the society, environment, and economy, which are interest not separate one. Sustainability is paradigm for thinking about the future in which environment, society, and economy consider are balanced in the vessel for the improvement quality of life. And sustainability is often through as a long-term goal, whereas sustainable development refer to many process and pathways to achieve that one. And today, education for sustainable development has been integrated into many global framework and convention related the key area for sustainable development. And a question here, how to define the level of sustainable development? So that we thinking about how to link between the sustainable development with the ecosystem services for the coastal habitat in which we can use the check of assessment to define when they apply the economic development there and what the ecosystem services change over time. For the coastal water, the ecosystem services can target the many things in here. For example, it is about the carbon store, coastal buffer, protection, also opportunity for tourists and biodiversity protection. Here, in the coastal area, we can target to three objectives. This is the mangrove forest, coral reef, and seagrass bed here. And this one, the ecosystem services for three dimensions here, it can combine together. For example, the coastal protection, maintain the structure of ecosystem, and associate with ecosystem services in the offshore to onshore direction. The second one is fishery are characterized by migratory species, and therefore protecting fishery is one ecosystem increase fishery per map there. Also, tourists benefit from the coastal protection and healthy fishery for multi-ecosystem. Fishery, tourist, carbon storage, and coastal protection. It can catalyze change in conservation practice, and it had been clearly. So ecosystem services can assess by data in observation, spatial distribution, long-term data set that can be provided by the observation data as well as remote sensing analysis data. For remote sensing, we had 3 platforms. The first one about the satellite. This is the long-term ago. We can absorb the data from the satellite. Also, we can do analysis. The second one is AUV. It's not only from the sky, but also from on the surface of water and under surface of water. Another one is mobile platform. This is used the stream by people so that we can get the data for that one. And with the underwater, the theory for remote sensing had made from sunlight and collect the data, collect the signal by the sensor there. But underwater here, we can see for that one, the signal had effect by water column there. So that we cannot get anything and get anything from deep water. We just only had the objective can collect the data just only the deep within the transparency zone. And another one is application of remote sensing for aquarium can apply with the habitat mapping for development of management plan for marine protection at the small level and marine spatial planning at the medium scale. Remote sensing data also provide the evidence on habitat modify the degradation for adaptive management under impact of increased human activity and climate change. Remote sensing data can provide the mapping activity for economic sector. For example, here is marine culture, navigation, tourism in the cultural area for interactive cultural management. Also, remote sensing data can provide the environmental disaster. For example, we can get the data for province of oil spill, algae bloom, sedimentation, and also population. All of data can help us to enhance appropriate intervention and minimization economic loss. And the GN, but not last, is remote sensing can help us to evaluation of effectiveness of environmental intervention such as rehabilitation and cultural recovery after human and natural disaster. However, when we apply remote sensing data techniques, we had to face several challenges because with the objective about water, we only find about the artifact collection, but with the objective underwater, we face several challenges for water clarity, water depth, and water richness, also current. And another one is closure and snow. With the water clarity, this can be if we had the good technique, we can be improve the objective underwater. And also visible light can penetrate up by water column. So that water classified is improved by this water classified is affected by organic and inorganic matter in the water column. The density of and the type of the subordinate matter effect have the visible line, and yes, it's called the absorption and scattering of light. So that is reduce the value or reduce the accuracy when we apply the machine analysis there. The second one is what the dip is. We know the line we had the 7 colors there, and with the blue color, this manifest further than red color in water. With only and blue color just only had the few meter in the water, and red color can go to the deeper than blue. So this means the shallow water and less 70 meter can improve the altitude underwater there. Another one is with the radar data. We cannot absorb the altitude underwater because the data just had disappear just a few meters there. The third one is about the roughness. Roughness of water can reduce the ability of the map subject further compared to calm and flat water. Another one is the water current. The dynamic strength of water due to tidal, wind, and ocean current can cause the water depth to variation and often a current mixing of water column, organic and inorganic matter, both of which have the two interpretation. The last one is about the cloud, sap, and smoke. You can find here when the sap here, it cannot absorb if the satellite, this one go to there. So for the underwater, the machine only detect the altitude within the water depth of Chamberlain zone. Here is we use the saturated depth, or we can use the KD. A dissolved atomic coefficient divide 1.7 in the culture water. In the culture water, this depth is about 15 meters when we apply the machine data here. And with our presentation, we would like to target the outlook here. This is the first one. We want to improve the machine techniques for the cultural habitat. In here, the first, you have to apply artifact collection. The Barbosa add-on 2015, they had reviewed, they thought that about 85% of paper had published is not geo artifact collection for that one. And within that, 55% paper it claimed that artifact collection had to improve the result of analysis. The second one is they need to grassrooting data because for not only the coral reef and seagrass based one, but also for the environmental data, they need to do with the localized authority so that they need to have the grassrooting data to improve the method. The third one is we had all mentioned about the limitation of this for underwater altitude. For example, with the seagrass and coral reef, if the altitude more than 15 meter SPOF in the K2 water, we cannot apply for that one. The second one is strategy for human resource for local people in demonstration cultural habitat mapping due to learning by doing. This means the people had to, for the local people had to improve their skill within. They cannot learn together, but they can learn by the work there. The third one is information of mapping result to society awareness for the local people. And the last one, we have to, maybe we can link between the cultural habitat mapping with sustainable development goal and ecosystem services here. Yes, thank you very much for your listening.
Thank you very much, Famitu. Now we open the question for 3 minutes. So do you have any questions? Very clear?
Yes.
Okay. No question?
The
So
location.
I asked Famin to make some keynote introduction presentation. So, but the order is changed. So I'm sorry. So, but it's your presentation compactly summarized some problems and also some to be solved. So thank you for your presentation. Okay, so do you have some comments or from me too? Okay.
Yes.
Okay. So if no questions, we move to next speaker. So thank you very much, Famin too. Thank you.
Yeah, thank you very much, Komatsu.
Yeah.
Yes,
So,
maybe I lead the meeting now because I go to the
okay.
sea.
Yeah,
thank you.
see you. Thank you. So we move to next presentation, coastal habitat mapping in Maluku province, Indonesia to support the SDG 14's goal by Sam Watwizen, DP, Indonesia. Sam, please.
Thank you, Komatsu Sensei. Please let me share my screen.
Share your slide.
Yes, please. Is everybody see my screen?
Yeah, but not a presentation. We can see, but not presentation.
Oh, yes, here is.
Launch your presentation.
No, I have already in the presentation.
Sam,
Yes?
Sam, could you make the full screen presentation?
Yes, I have already met this.
It's still in not in the full
Okay.
screen yet,
Oh. Here I say that my slide is in the presentation mode. Yeah. Okay. I don't know.
Yeah, if you go to I think to below of the screen, they have the 3 box. I think the small box one is the full screen, and on the right hand side of the 3 small box on the bottom on the left hand side of your screen. Because otherwise your screen is too small, difficult for those participants can see it clearly.
Oh yeah, yes, yeah. I'm sorry. How to do that?
Sorry, Mr. Sam, is in your site already full or not?
Yes, already full.
Or maybe you can stop sharing and sharing it again.
Oh yes.
Yes, select the one that full screen.
Yes. Maybe this. It is. You can see. Sorry.
not a presentation mode.
How
Yeah,
about
it's still not full screen. Yeah, can you take it full screen?
Some can I show your PowerPoint?
yes, yes, please. If you you
Okay.
you can So I stop here.
Yes, and you have to stop, and then Komatsu can share. Yeah.
Yeah. Okay.
No. Sorry. Okay.
Yeah. Okay. Can admin help me?
Yeah. Okay, Komatsu-san will help.
Yeah. Okay. Thank you very much. I will start here. Good morning, everyone. Today I will present our study result entitled Coastal Habitat Mapping in Maluku Province, Indonesia, to support the SDGs 14 goal. My name is Sam Worthesen. I belong to Research Center for Oceanography, Indonesian Institute of Science. Next, please. So what is the coastal zone? The coastal zone defined as a border or transition zone between land and marine ecosystem, which influenced greatly by the changes of the land and area and the sea. Next, please. Next. So in Indonesia, there are 3 tropical ecosystems, namely mangrove area, mangrove, seagrass, and coastal and coral reef. You can see here in the left side, we can see there's a mangrove area, and then after that seagrass, and then coral reef. This is 3 ecosystem is living in harmony. So this ecosystem is very high productivity. That is higher than the rainforest ecosystem. So they provide goods and environment services to the local community. Next slide, please. So regarding to the importance of the Maluku province, long-term commitment to monitor the coastal ecosystem is needed. This requires tools that provide frequent, widespread, consistent, effective, and efficient observation. So this can achieve by the remote sensing technique by utilizing the satellite data. Next slide, please. So we have 2 cases of the habitat mapping. The case 1 is mapping the seagrass bed as dugong feeding habitat in Ambon and Haruku Island using Landsat 8. Next slide, please. Next, please. The dugong is the one of marine herbivore mammal that listed in the red list of the IUCN. Sorry, before.
Okay.
Before, not finished, but before. Now, again, previous slide, please. Yes. So there's no. Yes, please. Next slide. Next, please. Next, please. Yeah, this one. Yeah. So the dugong. Sorry. It's too. So the dugong. No. Before, please. Before. I can come. Yeah. Yes, this one. Yeah. So the dugong is very depend on the seagrass bed. So mapping seagrass bed using remote sensing is important. So this study aims to map the seagrass bed in Ambon and Haruku Island that have been well known as the feeding habitat of dugong. Next slide, please. This is the map of the Haruku, Ambon Island, and the Haruku Island. So we make study on this area. Next slide, please. So this is Ambon around this area, around this area, and in Haruku Island, around along the coastal zone, along the coastal line of the area. So this figure show the seagrass in the Ambon in Y, and the Kalolo and Haruku village. Next slide, please. So we use the data Landsat data acquired on March 13, 2015, and here we conducted ground check using 62 and 66 transect in the east side of Ambon and the west side of Haruku Island, respectively. Here we use isocluster analysis to map the benthic habitat using 4 bands of Landsat, the blue, green, red, and near infrared band. And then the seagrass map, then we verified using the ground truth data. Next slide, please. Here's the ground truth data. This is Y in Ambon. In the middle is in the north of the Haruku Island, and this is an Haruku village in the southern south of the Haruku Island. Next, please. So here's the result habitat map of the study site. We can see we use this map is based on the isocluster analysis of 15 type benthic habitat, which then reclass again into 6 class. So we can see the dark blue is deep sea, and the light blue is seagrass grow in the slope area. And then the green and pink one is the dense seagrass in the reef flat area, and the white is the sparse seagrass in the sand. So if we in this, for example, in the habitat 3, the habitat 3 is dense seagrass in the reef flat. We can know the seagrass cover is about 67%, and in the Haruku is 87%. Next slide, please. So we calculate the accuracy of the map is in Ambon Island. We found the overall accuracy is about 73%, and in Haruku is slightly lower, about 68%. Next slide, please. This is 7 seagrass that we found in the Haruku and Ambon Island. The species number 3, number 5, and number 6. This is Halodule species and Cimodocea and Syringodium, and 6 is Halophila, is the seagrass species that dugong like very much. Next, please. Next slide, please. So it's the final detailed benthic habitat map in Ambon. We can see the white is the seagrass grow in the white sand and mixed with macroalgae. The light blue is seagrass grow in the reef slope with sand and rubble, and green is the seagrass grow in the reef flat with the sand and coral. So we can see also in the circle, the light blue circle is the species of seagrass. We found here Thalassea, Syringodium, and Cimodocea. And then the orange one is the Halophila and Halodulis. So we can see here the distribution of species. And we found the purple one is the feeding area of dugong. So we can see here in the picture, there's the dugong in the white sand is the dugong tracking, the dugong feeding track in this seagrass ecosystem. Next, please. This is a detailed map of habitat map in Haruku Island. We can see there's the same as we can see the same species. The light blue circle is the Thalassea, Syringodium, and Cimodocea species. and then the orange one is Halo Dule and Halo Villa. So we find in this area 3 feeding dugong area in the north around here, and then in the middle around here, and then the around in the south is around here. So we can see here that the dugong is the coincidentally with the seagrass bed that dugong like very much, such as the Thalassia, Syringodium, Halodule, and Halovilla. This we can see there's a feeding track, a white sand here. We can see the dugong feeding area. Next, please. So this is the species of seagrass that dugong like very much. Is based on the 122 dugong in the mouth of dugong and in the stomach content of dugong. So the green one is the species that the dugong like very much. So this is there's a problem with the conflict interest between dugong and fishermen. So dugong use the same area for feeding area, while fisher use the area for fishing ground. Next slide, please. So there's a problem. So here the solution is one is we ask the fisher to slightly move in the setting their net from the dugong feeding area, not in the seagrass area. So we can ask fisher to move their net. For example, in the white arrow, we can move because this is a dugong area. So we ask fisher to move their when they're setting the net, not in the feeding area, because it is always dugong entangled to the fisher net. So next slide, please. So if the fisher don't want to move, then we can ask the fisher to equip their net by using the finger. See, this is finger. When the finger is down, then the dugong avoid the area, so the dugong is not entangled to the fisherman net. Next, please. Here in the case 2, we map coastal zone ecosystem mapping in the East Seram District, Maluku Province. Next, please. This map the Seram Island. The study site is in the tip of the Seram Island. Is in the point of there's some small island over there. So we study the area of in the East Seram. Next slide, please. So here we use two satellite data, Sentinel-2 multispectral imager and Landsat 7 ATM. The Landsat, the Sentinel we collect in 2018, and the Landsat in 2001. So the Sentinel have a better characteristic because the rapid revisit time is only 5 days, and the spatial resolution is only 10 meters, while the Landsat 7 ATM is spatial resolution is 30 meters, with the revisit time is 16 days. Next, please. Here, this figure shows the concept of remote sensing for benthic habitat mapping. This is so that we have to make a correction. First is atmospheric correction. Two is a sun glint correction, as been, and then water column the correction. Because if we use two data, then we must if we use the two image data, then we must correct this effect. Next, please. However, as you seen in the picture, in the East Seram Island, there's a very large area of seagrass bed, but then this seagrass bed is in the shallow area, sometimes exposed to the air, and then so the water column correction is really not applied here, and the sun grain correction is also not applied. So we only make atmospheric correction. Next slide, please. Here we use the same isocluster analysis. This is the very simple one. We ask the program and computer to classify the benthic habitat into 39 classes. Next, please. This is the isocluster analysis of 39 class habitat. And then in the right hand is the ground truthing using a lot of transect in the field. So we found that 80% of the map match with the seagrass class. And then after that we reclass into 6 class: deep sea, land vegetation, dense mangrove, seagrass 1, seagrass 2, and seagrass 3. Next slide, please. This is the coastal ecosystem map of the East Seram district in 2018 using the Sentinel-2. With the green one is land vegetation. This mountain area is very great jungle over there. And then dense mangrove in the coastal area, and seagrass 1, seagrass 2, and seagrass 3 we can find here. Seagrass 3 is the dense seagrass. Another slide, please. This is the same image, but this is image from 2001. November 2001 using the Landsat TM. So we have 2 images. In the bottom we can see in 2001 the mangrove area is 1,400 hectares. In 2018 the mangrove area is 1,111 hectares. So there's a decreasing in mangrove area. And seagrass area we can see also the decreasing. In 2001 about 3,180 hectares, and in 2018 is only 2,500 hectares. So we can see there's a decreasing of mangrove and seagrass area. Next slide, please. So here's the image of the mangrove ecosystem in the Seram district. Is very nice. Mangrove over there, but the community of Seram cut the mangrove mainly for the firewood. Next slide, please. This is about at least there's about 15 species that we found, the mangrove species found in the Seram. Next slide, please. So this is a seagrass ecosystem. You can see a very large area, seagrass bed with the seagrass, and the seagrass is very dense, as you can see in this picture. Next slide, please. Here in Seram, we found 9 species of seagrass. You can see there's Halodule and Halophila and some Cimodocea. And this is the dugong like this species very much. Next slide, please. Beside the seagrass bed, there's a mixed species between seagrass and seaweed. We have a lot of seaweed associated with the seagrass. For example, the green seaweed and the red seaweed. There's and the other another species of seaweed, such as a brown seaweed. Next slide, please. So the huge seagrass bed and mangrove area in the East Seram district, Maluku province, support the very famous half-beak fisheries. This fish is international name is half-beak fish, but the scientific name is Hemirhampus, and local name we call ikan julung fish, ikan julung. So this fish processes into smoked fish. So the smoked fish, the julung smoked fish is very famous in Maluku province. And these fish are catch near to the mangrove area and seagrass bed area. Next slide, please. So some destruction of coastal ecosystem in the Seram district, people cutting mangrove, collecting coral for the building in the seagrass area. So seagrass become decreasing the area. And sometimes in the coral reef, they use bombing in catching the fish. Next slide, please. So the problem is the exploitation mangrove for firewood to smoke the julung fish. The local people in the Seram, East Seram, believe that the mangrove firewood make the taste of smoked fish is very good. So the people don't want use another wood. There's only use the mangrove firewood. And the local people living in small island, it is too far to collect wood from the forest in the mainland. So there's no alternative to use another kind of wood. And in the seagrass bed, people mining the dead coral for various purposes of building material, which cause the area of seagrass bed become damaged, and there's a trend to decrease. So decreasing mangrove and seagrass bed, causing the decreasing of the julung fish population. So this, according to the interview with the fisher aware that their catch has decreased by the 30 to 50% compared to 20 or 30 years ago. So fisheries cannot get the wage higher than 1 million rupiah per month, even during the peak season of the fish. So there's a problem over there. Next, please. So the solution is the use of alternative source of firewood. This is, for example, we use coconut fiber husk and the shell, sagu frond, walnut shell, or naturally fallen diet mangrove. Sometimes people cut the living mangrove, but there's a naturally fallen diet mangrove. It is better to choose this kind of wood. So sometimes there's a drift, big wood was up on the beaches, so we can use this. And during the smoke fish, we can use the liquid smoke. This is effective and efficient in controlling the taste consistently. And the liquid smoke can use repeatedly. Then we can save the firewood. And the other one is develop a stove system. So we suggest to utilize the effective heat energy during the fish processing. So because the stove is sometimes not effective, they lose the heat. But if you develop an effective stove, then we can save the firewood. In the seagrass, we ask the local government to prohibit the community from taking the dead coral that used for building material. And we suggest to establish the marine protected area around the good condition of mangrove and seagrass ecosystem. So julung fish, we ask to study in-depth study of fish biology, of julung fish biology and population dynamics. So how many fish can be exploited, and how when the spawning of this fish is known. and revitalizing the traditional local wisdom called sati. That's the wisdom of the Maluku people, that not to capture or to exploit certain resources such as julung-julung fish in a certain area. This is in the management area is closed area and closed system, closed area and closed season. Yeah. Next, please. So, in concluding remark that the simple method of unsupervised isocluster analysis and ground truth data is potential technique to map and manage the coastal habitat and their resources effectively and efficiently. The study showed that the problem in the coastal habitat, for example, in case 1, there's a conflict interest between dugong and fisher. In case 2, there's the destruction of the coastal habitat, mangrove and seagrass, that cause decreasing of julung-julung fish population. So the suggested solution in case 1 and case 2 is needed to be implemented to all stakeholders, otherwise it will be failed. So the study proved that remote sensing technology and application is able to generate the solution for the conservation area. I think, next please. So save our coastal area for the future of our children and our grandchildren. Next, please. Next slide, please. Thank you very much.
Yeah, thank you. So the time is not enough. I cannot accept the questions. So please, if you have some questions, please ask later. So thank you very much, Sam. We move to the next speaker.
Yeah, you're welcome, Sensei.
Yeah, and the next speaker is long-term changes in the coral reef ecosystem and the human impacts in Spelmonte Archipelago by Nurjana Nurdin of Hasanuddin University, Indonesia. Please. Okay, we can see your presentation. I cannot hear your voice.
Okay.
Okay.
Hello.
Oh, yeah, start.
Okay. Good morning, everyone. I would like to present our long-time research about long-term changes in coral reef ecosystem and human impact in Spelmonte Archipelago, Indonesia. I'm Nurjana Nurdin from Laboratory of Geospatial in Research Center of Marine, Coast and Small Island, Hasanuddin University, Indonesia. If Mr. Sam already talked a lot about the seagrass in Indonesia, in mangrove, a little bit about mangrove in Indonesia, I would like to focus about the coral reef in Indonesia. But for the first, let me show about the condition of coral reef in the world and to know the position of coral reef in Indonesia. We can see in the address homepage from Alien Coral Atlas. From this web, we can see about the coral reef condition of the world, but represented by bleaching of coral reef. We see this, the different color, it means the different condition of bleaching of coral. Red means of very strong, very large area in a bleached coral. And how about in Indonesia? From the data, Mr. Sam Office LIPI, the data 2017, we see that the condition of a coral reef in Indonesia start from 1993 until 2016. This is the newest data from LIPI. We saw that the largest area in the yellow line and the red line. This yellow line, it means the pure condition, and the red color line, it means the bad condition. Around 400. And then if we see the blue color, this the blue line, so the condition, the smallest area is the excellent condition, less than 10 coral reef in Indonesia. But for this session, I would like to share about our research. We developed a big data using geodatabase system, and we updating the data every year by ground truthing and image processing. We focus in Spermonde archipelago in Indonesia. Is one of the most small islands in Spermonde archipelago. We see this picture, this imagery. One island is near each other, and sorry.